Imagine waking up one morning to breaking news that sounds impossible.
All air from the entire Western Hemisphere has suddenly vanished.
Not thinned, not poisoned,
Gone.
as if someone carved out half of Earth's atmosphere with a cosmic ice cream scoop. Within seconds, an invisible wall of devastation erupts across the planet. On one side, the sky collapses into a pitch black void. On the other, hurricane force winds rush toward the empty hemisphere at more than 1,500 kilometers per hour, trying to fill the vacuum. Trees snap like matchsticks, skyscrapers crumble, oceans surge violently eastward, forming mega-tsunamis that rise hundreds of meters high. Birds are ripped from the sky. Dust, debris, and entire forests are sucked toward the atmospheric abyss. People living near the atmospheric boundary zone have less than 3 seconds before the blast of rushing air knocks them unconscious. Planes instantly drop out of the sky as one half of Earth becomes a deadly, airless, space like wasteland. Sound disappears. Fire can't burn. Water begins to boil at room temperature. Every living creature suffocates in moments. Meanwhile, the remaining half of Earth experiences a crushing atmospheric collapse as pressure imbalances tear through infrastructure, lungs, and ecosystems. A planet wide windstorm unlike anything in history begins, and it will not stop for days. Earth has become a world split in two. One hemisphere drowning in violent air rushing in, the other transformed into a silent, frozen vacuum. And all of this happens in the very first minute. Please like this video, subscribe to the channel, and comment your question below. What would actually happen if half of Earth suddenly lost all its air? It's a scenario so extreme that it sounds like pure science fiction, but it's rooted deeply in real physics, atmospheric science, and planetary mechanics. Our atmosphere isn't just a layer of air we breathe, it's a protective shield, a pressure blanket, and a life support system that stabilizes weather, temperature, and even the speed at which oceans evaporate. Removing it from one side of Earth would create one of the most violent chain reactions imaginable. In this hypothetical scenario, we assume an impossible but simple condition.
Course ordinance. Our source statements is beautiful. All we have been master the ground sadness, but the those. But there's a little thing we're attacking. And after the distance,
So, north, south, ocean, land, everything on that side of Earth is left exposed to the vacuum of space. Why is this scientifically interesting? Because the atmosphere behaves like an ocean of gas. And if you suddenly drain one half of it, the remaining half doesn't just balance out, it explodes toward the empty side with unimaginable force. That means extreme winds, global shock waves, boiling oceans, mass freezing, and possibly even tectonic consequences. In today's video, we'll explore step by step what happens to temperature, oceans, weather systems, human life, and the planet itself during this atmospheric collapse. From the first seconds to the first hour, to the long-term aftermath. The moment all air vanishes from one side of Earth, the remaining atmosphere behaves like a collapsing ocean of gas. One hemisphere is full, pressurized, and heavy. The other is a pure vacuum. That imbalance creates a violent, uncontrollable rush of air unlike anything Earth has ever experienced. What begins as a strong wind rapidly accelerates into a supersonic torrent, blasting across continents faster than the speed of sound. Entire cities are shredded before the shockwave even arrives. Trees, dust, soil, vehicles, rooftops, animals, everything loose is ripped from the ground and flung toward the empty side of the planet. It's not wind anymore. It's a global atmospheric stampede. As the air floods outward, a continuous sonic boom sweeps around the world. The force is so intense that even mountains begin to erode, with rock fragments carried into the vacuum like bullets. Nothing can resist the pressure difference. Even inside buildings, walls implode as the air inside tries to escape. But the oceans undergo an even stranger transformation, because the air-filled side still presses down on the water, while the vacuum side has no pressure at all. Sea levels begin tilting toward the empty hemisphere. Trillions of tons of water crash sideways, forming continent-sized tsunamis that slam into the exposed basin. The moment the water reaches the vacuum, it flashes into vapor, exploding violently into steam clouds. These steam blasts hurl debris kilometers into the air, adding chaos to the already collapsing environment. But the region where atmosphere meets vacuum instantly becomes the most lethal zone on Earth. Humans caught anywhere near the boundary lose consciousness in seconds. Their lungs can't withstand the sudden pressure drop, eardrums burst, blood vessels rupture, bodies are lifted and thrown hundreds of meters before the rushing wind tears them apart with airborne debris. Survival is impossible unless someone is deep underground or inside a pressure sealed bunker. And this is just the beginning. The planet hasn't even started adjusting its climate, temperature, and natural systems yet. The true global disaster is still unfolding. As the atmosphere continues pouring into the empty hemisphere, Earth enters its next stage of collapse, the transformation of climate and temperature on a planetary scale. The vacuum side instantly becomes a frozen, airless wasteland. With no air to trap heat, the surface temperature plunges below 100 T only in hours, similar to the moon's nighttime side. The ground begins to crack as moisture inside soil and rock expands into ice. Rivers, lakes, and even shallow oceans start boiling from pressure loss, then freeze solid as their vapor escapes into space. The vacuum hemisphere turns into a dead, silent landscape where no weather, sound, or life can exist. Meanwhile, the surviving hemisphere is thrown into atmospheric chaos. With half of Earth's air gone, the remaining side experiences a dramatic pressure drop. Storm systems collapse and reform wildly, creating unpredictable superstorms. Clouds stretch into enormous spirals as they're pulled toward the boundary zone. Temperatures spike during the day and plummet at night because the thinner air can't regulate heat. Forests ignite in massive firestorms as frictional winds rip through dry landscapes, while other regions drown in unstoppable rainfall caused by warped moisture patterns. As the oceans tilt and surge, coastlines on the surviving hemisphere suffer continuous flooding. Low-lying countries disappear underwater within hours. Ports, coastal cities, and islands are reshaped by violent tides that never stabilize. Earth's rotation also begins to feel the imbalance. With trillions of tons of air and water shifting to one side, the planet wobbles slightly, altering day length by fractions of a second small, but enough to disrupt satellites, GPS systems, and orbital stability. Wildlife suffers next. Birds cannot fly in the chaotic winds. Marine life is torn from its ecosystems as pressure changes shock entire ocean layers. Even deep sea animals experience stress as the upper ocean becomes violently unstable. Crops fail almost instantly due to unpredictable temperature swings and loss of pollinators. Human civilization begins collapsing during this stage. Power grids fail from continuous storms. Communication towers are destroyed, air travel becomes impossible, supply chains break, billions face starvation, infrastructure damage, and atmospheric instability, all while the vacuum side grows colder, darker, and more uninhabitable with every passing hour. And yet, the planet's long term consequences haven't even reached their peak. Days after the atmosphere collapses into the empty hemisphere, Earth begins settling into a terrifying new long term reality. The vacuum side, now permanently exposed to space, transforms into something closer to the surface of Mars than Earth. Without air, ultraviolet radiation and cosmic particles strike the ground unfiltered, bleaching landscapes and breaking down organic material. Dust layers form across deserts, forests, and cities frozen in place. Buildings that survived the initial implosion start cracking and collapsing as thermal cycles swing wildly between scorching sunlight and deep space cold. Nothing decays normally. There is no weather, no microbes, no wind, only desolation. On the surviving hemisphere, life doesn't return to normal either. With only half an atmosphere remaining, global pressure stabilizes at levels similar to high altitude mountains. Breathing becomes difficult everywhere. Humans require oxygen support to work, travel, or even sleep safely. Agriculture collapses as plants fail to grow properly under reduced pressure and unstable temperatures. Entire biomes vanish. Most insects die off, breaking food chains. Forests shrink, grasslands dry out, and oceans lose oxygen as their circulation patterns break. The climate enters a runaway feedback loop. The thin atmosphere loses heat rapidly at night but overheats during the day, creating a harsh, desert like global environment. Storms no longer circle the planet. They form erratically, unleashing sudden bursts of lightning, torrential rain, or intense drought. Coastal regions remain flooded from permanently displaced sea levels, while inland areas face dust storms created by the weakened atmosphere. Humanity retreats into sealed habitats, domed cities, and underground shelters. The surviving technology focuses on generating artificial pressure environments, recycling air, and growing food in controlled ecosystems. Entire countries reorganize around breathable zones. Long term survival demands constant engineering. Earth itself changes shape gradually. The mass redistribution of air and water affects tectonic stress. Earthquakes strike regions that were previously stable. Volcanic activity increases in some areas as the crust adjusts to the new imbalance. The planet is still Earth, but it feels alien, hostile, and unpredictable. And eventually, both hemispheres reach a grim equilibrium, one a silent, frozen vacuum, the other a thin, struggling atmosphere, fighting to sustain what little remains of life. The moment half of Earth's atmosphere vanished, the planet entered a chain reaction that nothing could stop. Air accelerated toward the vacuum faster than sound, tearing apart landscapes and cities in minutes. Oceans surged sideways, boiling and freezing as they spilled into the exposed hemisphere. Lives ended instantly along the boundary where pressure, temperature, and wind combined into the deadliest zone Earth has ever known. As hours passed, the vacuum side transformed into a lifeless shadow world, frozen, silent, and stripped bare by direct exposure to space. The surviving hemisphere became a chaotic realm of thin air, unstable storms, deadly temperature swings, and collapsing ecosystems. The very balance of the planet shifted as water, wind, and atmospheric mass redistributed unevenly across the globe. Day by day, humanity fought not only the environment but the physics of a world that no longer supported life as it once had. In the long term, Earth found a new equilibrium, one half a cold, airless desert, the other a thin aired wasteland, where only engineered habitats allowed life to continue. Civilization shrank, technology replaced nature, and the planet became a reminder of how fragile an atmosphere truly is. This scenario may be impossible, but it highlights a powerful truth. Our hemisphere is not just air, it is the boundary between life and nothingness. Protecting it is not optional. It is our single most important lifeline.